Why don't railways use concrete? Next time you're near a railway crossing or watching a train rush past, take a look at the ground beneath the tracks. You'll see something strange. Instead of solid concrete or a smooth pavement, train tracks rest on millions of rough, jagged stones. And that raises an interesting question. Why would engineers trust trains weighing thousands of tons to sit on loose rocks? It sounds wrong, but it's actually one of the smartest engineering solutions ever created. Today, we're uncovering the hidden purpose behind railway stones and why the simple design has kept trains running safely for over 200 years. Trains are incredibly heavy. A fully loaded freight train can weigh thousands of tons, putting enormous pressure on the ground beneath it. If rails were placed directly on soil, the weight would slowly compress the earth. Tracks would sink, they would bend, and eventually they could fail completely. So engineers needed a way to spread that weight over a much larger area. Think of railway tracks like layers. At the top are the steel rails. Below them are horizontal beams called sleepers or ties. And beneath those sits a thick layer of crushed stone. This layer is called ballast, and it does most of the hard work. Here's something surprising. Train tracks aren't permanently fixed into the ground. They actually float on top of the ballast. The weight of the stones and the friction between them hold everything in place. This allows the track to flex slightly as trains pass over. That small amount of movement absorbs vibrations and reduces stress, preventing cracks and damage that could happen if the track were completely rigid. But not just any rocks will work. Railway ballast is made from crushed stone with sharp, jagged edges, and that's intentional. If engineers used smooth, round stones, they would roll over each other like marbles under pressure. The track would shift and become unstable. Jagged stones, however, lock together. Their rough edges interconnect, creating a strong and stable surface that resists movement while still allowing slight flexibility. It's the perfect balance between strength and motion. The stones also solve two major problems that railways constantly face: water and plants. When it rains, water needs somewhere to go. If tracks sat on solid concrete or bare soil, water could collect, causing rust or turning the ground into unstable mud. But ballast works like a giant drain. Water flows through the gaps between stones and away from the track. And those same rough stones make it extremely difficult for weaves to grow. Without plants breaking up the foundation, the track stays stable for much longer. Even the word ballast has an unexpected origin. Long before railways existed, sailors used heavy stones to stabilize empty ships at sea. These stones were placed inside the ship to add weight and prevent it from tipping in rough waves. When ships reached port and loaded cargo, they often dumped the extra stones onto the shore. Early railway engineers noticed these piles of heavy rock and realized they were perfect for stabilizing train tracks. They adopted the idea and even kept the name. So the next time you see railway stones, remember, they aren't just rocks. They spread weight, absorb vibration, drain water, stop weeds, and keep trains running safely across the world. Simple materials, brilliant engineering, and a hidden history beneath every track.